Okay, section 4.2 is going to tie into 4.1 with this idea of using the square root property. The only difference is we're going to do a little exercises here to start to set this up. So let me just explain. So if you notice here, I have x squared plus 18x plus 81. If you were to factor that, looking for factors, I'll just kind of do it off to the side. So it's a trinomial, so you got to remember your factoring. So if the first terms are x's because it multiplies to x squared, I'm looking for factors of 81 that add to 18. Well, we go, well, geez, that's 9 times 9 is 81, and 9 plus 9 is 18. Well, x plus 9 times x plus 9 is x plus 9 squared right here, equal to 6. And then we know what to do from here. This is a quadratic and formula. We take the square root of both sides and get the two solutions. So whenever we start talking about solving quadratics, your first choice, if you're not told what to do, is to see if you can factor it, because that'll be the quickest and easiest. If you can't factor it, perhaps if it fits, you can use the square root property like we just did in the previous. But if it's of a certain form that we're going to talk about, then what we're going to do here in this unit is talk about completing the square. We're going to turn it into something that we can use the square root property. And again, this makes it pretty easy to solve. So let's look at how do we turn something into a perfect square trinomial. Okay, and so here they talk about how to complete the square, right? And so whenever you have on this situation, this would be on one side of the equation, a square term and then some coefficient times x, you can turn this into a perfect square trinomial. Okay, and the way you do that, so here's an example. So I have x squared plus 6x. So what do? I identify the coefficient of the x term. Well, it's a 6. Okay, and then it says, what do? You take half that number. So half of 6 is 3, and then you square it. So 3 squared is 9. So I would quickly determine that I need to add a 9 to turn this into a perfect square trinomial. So again, I take half of 6. So 6 divided by 2 is equal to 3, and then 3 squared is equal to 9. And so you can see that if I add that 9 to the original two terms, I have a perfect square trinomial, so that could be written as x plus 3 squared. So the first part of this is just to get you comfortable with being able to create a perfect square trinomial. So this is right out of the homework. And what they do is they want you to figure out here in this first colored in square, what value needs to be added to make this a perfect square trinomial, and then you rewrite it as x plus or minus something squared. And so again, what do? You can see I have it written here already. You take the b term and divide it by 2. 14 divided by 2 is 7. 7 squared is equal to 49. So the missing value here is going to be a 49. Okay, so in their homework, you type in 49, and then they ask, okay, so if you write this in factored form, what is this? Well, x squared minus 14x plus 49 as a perfect square trinomial. If you were to factor this, it would be x minus 7 times x minus 7. So in factored form, the first term, of course, the square root of x is x. The square root of 49 is 7. And then you keep the sign of whatever is in front of that b term. So in this case, a minus sign. So this would be x minus 7 squared. If you ever have any doubt, you can FOIL it, and you will see that you will get x squared minus 14x plus 49. Okay, so this is easy to turn it into a perfect square trinomial. So for example, here, what missing value would make this a perfect square trinomial? Well, again, I show you the work. 20 divided by 2 is 10. 10 squared is 100. So the missing value here is 100. And then to rewrite that as a perfect square trinomial would just simply be x minus 10 quantity squared. Okay, so take a minute and go ahead and do these next two. So go ahead and pause the video, and then I'll come back here in a second. Okay, so hopefully you did these. So 12 divided by 2 is 6. And then if I square it, I get 36. So the missing value is 36. And if I wrote this as a perfect square, this is going to be x plus 6 squared. Why plus? Because this is a plus sign right here. Here we have a minus 1. So minus 1 divided by 2 would be 1/2. And if I square it, doesn't matter whether it's negative or positive, it's always going to come out positive. This is going to be equal to 1/4. So my missing value is 1/4. And then the perfect square would be x minus 1/2 quantity squared. Okay, so not very difficult to turn something into a perfect square trinomial. Okay, so let's do a few problems. This first problem, again, if you're going to use completing the square, you want the f terms to be on the left and the number on the right, which it is. But understand that these many of these problems, these could be factored. So I'll show you that if you tried to factor it, well, you'd get the 24 over to the left and have it equal to 0. So if I had f squared minus 10f minus 24, then it's a trinomial. So I'm looking for factors of negative 24 that add to negative 10. That would be negative 12 and a plus 2. And so if I set each factor equal to 0 and solve it, I would get 12 and negative 2. So that's a really quick way to get a solution. But to keep the math easy here initially, we're going to do this with completing the square. And so I've got it in the form that I need. So my first step is go ahead and complete the square on the left. And so half of 10 is 5. 5 squared is 25. So if I add 25 to the left, then what do I got to do? I got to add 25 also to the right, because whatever you do to one side, you got to do to the other. And so if I go ahead and then rewrite this as a perfect square trinomial, the left side is going to be f minus 5 squared, just as we've done, and 24 plus 25 is 49. And now we're kind of right where we need to be. We take the square roots of both sides. So when I do that, I end up with f minus 5 is equal to plus or minus the square root of 49. Okay. And so 49 is the square root of 49 obviously is going to be equal to a plus or minus 7. Okay. So when I add 5 to both sides, I'm going to have f is equal to 5 plus the 7, and f is equal to 5 minus the 7. The plus or minus 5 plus 7 is 12. 5 minus 7 is negative 2. So I get the same answers that I would get if I factored it. Okay, but I think you would agree that factoring was a little bit less work. So factoring would be the logical first choice, but we're going to practice using the square root property. Now this next one, factoring isn't going to work. If I subtract 171 from both sides, I'm not going to get something that's factorable. And so, but this sets up easily to be completing the square because I don't have a number in front of the a squared term, and I got a nice number here that can easily be cut in half and squared. So what do? I'm on the left side. I'm going to 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 to both sides of this equation. And when I do that, the left side, I've created a perfect square of x minus 3 squared. The right side is 180. Then I take the square root of both sides. That gives me a minus 3 is equal to plus or minus the square root of 180. And previous problem, I'm not going to go through it again, but square root of 180 simplifies to 6 square roots of 5. And so when I then go ahead and add 3 to both sides, you can say I get 3 plus 6 square root of 5, 3 minus 6 square root of 5. If you have the choice in your software, you could do 3 plus minus if you have a plus minus symbol, square root of 5. So this is really two solutions right here. These cannot be combined together because they're like terms. So these are exact answers. This is what you would leave it as. Okay. Okay, so This would be a classic example of when it would be easiest to use this. You can't factor it. Completing the square is going to be pretty simple. Over on this one here, um, what do I want to do? Well, first thing I need to do is get the 24 to the other side. So I would subtract it. So I'd have x squared minus 14x is equal to a negative 24. Then half of 14 is 7. 7 squared is 49. So x squared minus 14x plus 49 is equal to negative 24 plus 49. This is a perfect square trinomial, so it's going to be what? X minus 7 squared is equal to 25. And then take the square roots of both sides. That gives me x minus 7 is equal to plus or minus 5. So when I add 7, I'm going to x is equal to 7 plus or minus 5. So that means 7 plus 5 is 12. 7 minus 5 is 2. So there are my two solutions. Okay, the next problem, if you read the words, in order to complete the square, you want to have this leading term, coefficient, this coefficient of the x squared, you want it to be a 1. You don't want a number here. If there is a number and you want to complete the square, you want to get rid of it. So the problems we're going to do that I want you to complete the square to make the math easier. Everything will be divisible by 3. So the first step you're going to do is go ahead and add 15 to both sides to get it set up to start the completing the square process. So there, I've moved the negative 15 to the right, made it plus 15. But I got to get rid of this 3 coefficient, so I need to divide everything, both sides of the equation, by 3. So there is the division by 3. And you can see that that gives me x squared minus 4x is equal to a 5. And at that point, I just go as before. I'll go ahead and 4 divided by 2 is 2. 2 squared is 4. So I will add 4 to both sides. That gives me a perfect square trinomial on the left. X minus 2 squared, 5 plus 4 is 9. Take the square roots of both sides. So x minus 2 is equal to plus or minus square root of 9. That means x is equal to, by adding 2 to both sides, 2 plus 3, which is 5, and x is equal to 2 minus 3, doing the plus minus 3, the result of the square root of 9. So here are my two solutions right here. Okay, so again, the homework, let me pause this for a second and I'll get right back. Okay, so here's a couple homework problems. You can see I already wrote the answers in, but they're giving you these quadratic equations right here, and they're forcing you to rewrite this so that it's set up for completing. You're going to do completing the square so you can solve it using the square root property. So they want you to take it from here and put it in this form. So remember, what you want to do is isolate the p terms on one side, the constant on the other. So the first thing you might do is add 48 to both sides. And then I want to get rid of the negative 3. That's the coefficient. So I divide everything by negative 3 because a negative divided by a negative is a positive. And when I do that, I'll end up with p squared plus 10p is equal to a negative 16. Now I just go ahead and create the completing the square. Half of 10 is 5. 5 squared is 25. So I'll add 25 to both sides. And when I write this as a perfect square, I got p plus 5 quantity squared is equal to 9 because negative 16 plus 25 is 9. So the first solution is rewriting it in this form. They told you right here to do that. And then the next step is they want you to go ahead and solve that. So this is simple. We've done a number of these. Take the square roots of both sides. I'm just going to go ahead and delete it. It gives me p plus 5 equal plus or minus square root of 9, which is plus or minus 3. So when I move the 5 to the right by subtracting it, I end up with negative 5 plus 3 is a negative 2. Negative 5 minus 3 is equal to a negative 8. So negative 2, negative 8 would be the two solutions. Okay, we'll do this other one real quick. You can pause the video if you want to try it, but I'll go ahead and start it. So I want to get this 17 to the other side. So let me go ahead and subtract 17 from both sides. That gets rid of it on the left. That gives me a negative 12 on the right. I got to get rid of the 3. So what do? I'll divide everything by 3. That gives me y squared minus 4y is equal to a negative 4. Now I can complete the square here. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. Then rewrite this as a perfect square. So this is y minus 2 squared is equal to minus 4 plus 4, 0. So this is what you would type in here. And then we would solve it. Well, we would take the square root of both sides. Square root of 0 is 0, not plus or minus, because 0 doesn't, when you take the square root, it's just 0. If I add 2 to both sides, I simply get y is equal to 2. So this simply has a value of 2. Okay, so I hope you agree this is not terribly difficult. A couple of word problems. I'm just going to explain them and then try to do these. So listen to this and try to do it on your own. But there's some things you got to remember from your old algebra classes, right? So a rectangular garden has a length that is 4 meters longer than its width. The area of the garden is 60 square meters. Find the dimensions. Okay, well, the formula for area, they gave it right here, is length times width. But the key thing is I got to only use one variable in my equation. So width, they didn't say much about, so I'm just going to use W for the width. But for length, it says that it's 4 more than the width. So I'm going to rewrite length as equal to 4 plus W. And so I'm going to use these two values because they only contain a W for length and the width. So 60 is equal to length times width. I'll do the width times 4 plus W. If I distribute, I get this, and now I'm set up right here to go ahead and complete the square. Half of 4 is 2, squared is 4, so I'm kind of rewriting the order here. So the square term, so there's my perfect square trinomial. I'll add 4 to the left. That gives me 64, and that's W plus 2 squared, and then, as always, solve it. And so square root of 64 is 8. I'm only going to use the plus 8 because the negative 8 would result in a negative width, a negative length. Can't have a negative number. And so when I subtract the 2 here, I get width is 6. Okay, so if the width is 6, the length is 4 more than the width, so 4 plus 6 is equal to 10. Does it make sense? Well, yep, 10 times 6 does equal 60. So there's the area, and the length is 4 more than the width. So it makes sense. Okay, last one again, I'm just going to walk through this, but they give you the equation for this rocket, right? And the height is a function of time. And here's the equation they give you. And they ask you at what time will the rocket reach a height of 45? So this height is going to get replaced by the height that we're looking at, 45 feet, and we want to know what time does it hit it. Well, when you launch the rocket, it goes off the ground, it passes through 45 on the way up, and then gravity takes over and it passes 45 feet on the way down. So there'll be 2 times that we'll be at 45 feet. So when I substitute 45 in for the height, okay, again, I want this to be in such a way that I can solve this using completing the square. So let me get rid of this 30 by subtracting 30. So 45 minus 30 is 15. Now I then have to get rid of this negative 5 coefficient in front of the square term. So I'll divide everything by -5. So here's the three divisions, and that results in this quadratic. Here it's set up to complete the square. Half of 4 is 2. 2 squared is 4. So I add 4 to both sides. That gives me this perfect square is equal to a 1. Take the square roots, gives me t minus 2 is equal to plus or minus 1. When I add 2 to both sides, I'll have 2 plus 1, which is 3 seconds, so that's on the way down. And the 2 minus 1 is 1 second. That's on the way up. So there are the two times that the rocket passes through 45 meters. Okay, that's the end of 4.2.